before we get started with units and dimensions, I want to talk about three different types of unit systems. That is the SI, the CGS, and the US Customary system. CGS system, for those of you that might not know, is known as a centimeter grand system, and the US is the US Customary system. All three of these units are very common when it comes to doing engineering calculations, engineering courses, and really anything that involves adding and trying to figure out quantities of measurements, values, so on and so forth. There are other systems out there, but the SI, the CGS, and the US are very common systems in the United States. And for the remainder of our playlist, these are going to be the three different units that we're going to be talking about. So, with that out of the way, let's start talking about some of these measurements. So, let's talk about some common base units. A very common base unit is length. Now, length in SIs is denoted with M, also known as meters. For the CGS, centimeters. And for the US, feet. It can also use inches. So feet and inches, depending on what you are doing, you can use either or. Another very common base unit is mass. Now for mass, for SI, kilograms are the common unit. For the CGS, it'll be grams. And for the US Customary, it will be pounds. Another base unit is time. Now, unlike length and mass, time is common among all three units, and matter of fact, common among all unit systems. So, seconds, hours, minutes, so on and so forth. Days, months, weeks, centuries, decades. These are all the same among all unit systems. So, time is one of those where you only have to memorize once. Another base unit is temperature. Now, there are two different types of temperature units or measurements. The one that I'm going to mention right now is known as the common temperature scale. For the SI, that means you'll be using Celsius. For the CGS, you'll be using Celsius as well. And for the US Customary system, you'll be using Fahrenheit. So, what is that other common unit for temperature? It's absolute temperature. Now, the absolute temperature for the SI, or in SI, is known as a Kelvin. The same goes for the CGS. And for the US system, it's called the Rankine. And that's how you spell Rankine. So, you might be asking, what's the difference between temperature and absolute temperature? And to keep it simple and brief, the temperature, or the common temperature, is basically just an arbitrary scale that's used to determine whether things are cold or hot. Very common and basically used all around. Absolute temperature, on the other hand, also very common. Basically represents the absolute lowest limit a state of matter can reach. In this case, absolute zero being the limit or the bound, so to speak. A little bit more on that on thermodynamics. So temperature and absolute temperature, both of these units are very common and will probably be used interchangeably as you do your engineering calculations or your courses. Let's talk about another unit, and that is quantity. Now, the unit for quantity in SI is moles. For CGS is also moles, and for the US is the pound mole. Mass is basically the amount of physical matter that something is, and quantity is the number of atoms, or how many atoms make up that physical matter. So, with that being said, let's talk about another unit, and that is force. Now, force for SI is denoted with newtons, or the letter N. For the CGS, we have dyne, denoted with dyn. And for the US system, we have pound force, which is the pounds with a subscript of a lowercase f. Now, I do want to point out, for the US system, there is something called a slug. And we'll get more into what a slug is, but this is also another very common unit of force when it comes to the US system. But for now, we'll stick to the pound force. Another very common unit is energy. Now, for the SI, that is going to be a joule. For the CGS, that is going to be an erg, ERG, and for the US, it's going to be a foot pound. All of these units represent energy. And we'll talk about a little bit about what an erg is and a pound or a foot pound when we start talking about unit conversions and converting from one to another. Another common unit is pressure. Now, for the SI, it's typically a Pascal, but there are other units that we'll talk about, but commonly Pascal. For the CGS, it is a BAM, BAM, but typically when you're writing out the unit, it's just BA. And again, there's other units that we'll talk about. And for the US, we have a PCF, which is pound per square feet, or a PCI, which is pound per square inches. Let's talk about power now. Power for the SI is a watt. And for those of you who've taken physics, chemistry, this is the same thing as saying a joule per second. One way to think about power is basically an energy per second. How much energy does something produce per unit of time? So for SI, it's going to be a watt. For CGS, that is going to be 1 erg per per second. And for the US system, very commonly is horsepower, HP. Another very common one is BTU, and we'll talk a little bit more about those two. Let's talk about velocity. Now for velocity, the SI unit is meters per second. For CGS, is centimeters per second. And for US, it is feet per second. Also, very common is miles per hour. Acceleration, when it comes to SI, is meters per second squared, centimeters per second squared, and feet per second squared. Now moving on to area. For SIs, typically is meters squared, centimeters squared for CGS, and feet squared. If we take it up a dimension and we bring up volume, it's basically going to be cubed, meters cubed, centimeters cubed, and feet cubed. The next unit that is very common is momentum. Now the units for momentum for SI are kilograms times meters per second. For CGS is grams times centimeters per second. And for the US, it is a slug times feet per second. If you don't recall what momentum is, it's basically mass times velocity, and that's where we get the kilogram times meters per second, and the same for the other two units. A little bit more on that in a later video. Another very common one is frequency. Now, frequency in SI is hertz, and CGS also hertz, and in the US, RPM. Now there are other units that I'm not necessarily talking about, such as electrical current and other stuff, but for our purposes and for the purposes of this playlist, I wanted to keep with these units, as these units are going to be much more common when it comes to solving problems or doing calculations. So now let's talk a little bit about converting from one set of units to another, and a little bit about dimensionless quantities and what they are and how they can be used. And let's start with temperature. Now, as I mentioned earlier, we have common temperatures, which are Celsius and Fahrenheit, and we have absolute temperatures, which are Kelvin and Rankine. So let's say that we want to go from Celsius to Kelvin. The formula for that is Kelvin, or K, equals to whatever your degree in Celsius is, plus 273.5. This formula will convert Celsius to Kelvin. Now, how about if we want to go from Kelvin to Celsius? It would simply be this same formula, just rearranged a little bit differently, where our degree in Celsius would be our Kelvin minus 273.50. How about if we want to go from Fahrenheit to Celsius? The formula for that is degrees Celsius equals F, or your degrees in Fahrenheit, minus 32, all of this in parentheses, times 5, let me do that again, times 5/9. And that will convert your degrees in Fahrenheit to Celsius. If you want to do the opposite, from degrees Celsius to degrees Fahrenheit, all we have to do is rearrange the equation, basically solving for F, similar to the Celsius Kelvin, and that will give us C times 9/5 plus 32. If I want to convert Fahrenheit to rankings, R equals degrees in Fahrenheit plus 459.67. And kind of similar to the Kelvin Celsius, if I want to Fahrenheit, it's going to be degrees in ranking minus 459.67. So these are all the conversion rates between temperatures, between common and common temperatures, or common to absolute, and kind of vice versa. So let's touch upon quantity for a little bit. Now, what I did not mention for this is that quantity is the moles or the pound moles. There is a number associated with molecules, a number of molecules or ions or particles or whatever that could be. That number that shares a relationship between particles, atoms, and moles is known as Avogadro's number. Now, this number in SI and CGS is 6.022 times 10 to the 23. This is a number that you're going to be using if you want to convert from moles to particles or atoms or whatever. Now, I mentioned this is SI CGS. However, for the US, this number is a little different. The number is 2.732 times 10 to the 26 atoms, ions, particles, whatever that is. Remember, Avogadro's number for both the CI and CGS are the same, and the US is there. Staying on the same topic as force, we talked about dying. Now, one dying is equal to 1 gram times 1 centimeter per second square. This is the force unit for the CGS. Let's move on to energy. We said for the CGS that the unit was erg. Now, 1 erg is equal to 1 dyne times 1 centimeter. Or another way to think about it is 1 erg is equal to 1 gram times centimeter per second squared times 1 centimeter. And if we cancel those out or combine like terms, we get centimeters squared per second squared. And kind of coincides with the energy unit. Now let's move on to pressure. Now let's stay with the CGS. And we said for CGS, the very common unit, it was called BAM, which can be abbreviated as BA. 1 BA is equal to 1 dyne per 1 centimeter square. When we talk about the US system, if you remember, we said it was PSF or PSI. So 1 PSF or 1 pound per square feet is the same thing as saying 1 pound force per feet squared. One PSI, on the other hand, is the same thing as saying 1 pound force per inches squared. So in both cases, either or, as I mentioned previously, they could be used interchangeably in whichever case. And lastly, the Pascal. Now, shifting over to the SI units, we said that 1 Pascal is the same thing as saying 1 Newton per meter squared. Now, Pascal is a very common unit of pressure within the SI units, but there are other units for pressure that are also very commonly used other than the Pascal or the kilopascal. So some of those units are as follow. We have a bar, which can be abbreviated as BAR. This is mostly used for gases and usually seen in chemistry, physics. We also have milliliters in mercury, very common unit when it comes to more chemistry stuff. We also have torr, which is also pretty commonly used for gases, usually that are inside a container or something like. Very similar to the bar. Bar and torr are kind of used for that aspect for gases. And the last one is ATM, which is another way of saying atmospheric pressure. So that unit is usually seen in physics and chemistry. Kind of same thing, also kind of used to represent gases or gaseous states. All of these 4 different units for pressure are very common. So you could see a Pascal, You could see a bar. You could see an ATM, torr, or even milliliters of mercury. So let's point out some very common unit conversions. 1 kilopascal is the same thing as saying 1,000 pascals. 1 megapascal, which is also pretty common, is the same thing as saying 1 million pascals. 1 bar is the same thing as saying 1,000 pascals. Let's lift this up a little bit. One torr is the same thing as saying 1 over 760 ATM. 1 ATM is the same as saying 101,325 pascals. Let's make a little bit more space for a few more. For the ATM, it can also be represented as 760 milliliters of mercury, or 760 torr.